Okay, let's dive right into this foundational engineering marvel. Welcome to the Explainer. Today, we're looking at something most of us literally walk over every single day without ever realizing the incredible engineering happening right beneath our feet. We're talking about the hidden skeleton of a building, specifically the plinth beam. If you've ever wondered how massive, crushing loads are seamlessly transferred into the subsoil, or, how walls stay perfectly crack-free for decades, well, the answer lies in the dirt, the steel, and the concrete. So get comfortable as we decode the blueprint for building safety. Here is our blueprint for today. First, what is a plinth beam? Then, laying the groundwork, building columns and walls, casting the plinth beam, backfilling and compacting, and finally, why plinth beams matter. Let's get to work. So, before any digging begins, we really need to understand exactly what we're building. First up, what is a plinth beam? Think about the downward load mechanics of a structure. In civil engineering, a plinth beam isn't just a standard slab. It's a highly reinforced concrete beam built right at the plinth level, which you can basically think of as the dividing line between the substructure underground and the superstructure above ground. Its absolutely vital job is to connect the columns, distribute the massive structural load evenly into the foundation, and prevent differential settlement or cracking across the building's entire footprint. The team over at Kex Construction Engineering actually hit the nail on the head here. They say the goal is to tie the building's columns together at the plinth level. It's essentially like pulling a really tight belt around the waist of the building's foundation. And that right there is the core mission of our build today. Because if those columns aren't tied together, they act independently. And well, that is exactly how you get structural failure. Moving right along to section 2, laying the groundwork for a typical shallow foundation. Everything starts with a hole in the ground. Step 1 is excavation, usually down to a depth of about 900 millimeters. But here's where the science kicks in. You don't just toss steel and concrete into the dirt. No way. Step 2 is pouring 75 millimeters of what's called lean concrete at the very base. This is super important because it acts as a barrier to stop the steel base reinforcement from touching the soil and corroding over time. Then, step 3, you provide a 50 millimeter concrete cover right on top of that. It is all about protecting that steel from rust. Once your protective layer is down, you bring in the steel. The builders prepare and fix the base reinforcement using Y12 rebars. These are serious, heavy-duty steel bars, and they're laid out with a strict 200 millimeter center-to-center spacing. And guys, this isn't a guessing game. Being just a single millimeter off can drastically shift load-bearing dynamics. These rebars absolutely must be perfectly aligned and well placed on those concrete covers we just talked about. If this grid is off, the structural integrity of the whole column is compromised from day one. All right, section 3. Now we're moving vertically out of the ground to start building columns and walls. Let's see how this builds up. Step 1 is the installation and alignment of the starter column rebars. These vertical steel bars will eventually become the main pillars of the building. Step 2 is all about precision. Engineers inspect these bars to make sure they align perfectly with the center lines and the future block wall lines. Think about it. If a column is twisted here, the walls just aren't going to sit straight later. Once everything passes inspection, step 3 is a massive pour of a 1200 by 1200 by 300 millimeter concrete base. That creates a heavy, solid anchor for the entire building. Next up, step 1 here, the foundation, block walls are carefully set out and laid, ensuring proper alignment all the way around. Then, step 2 comes the shuttering for the starter columns. That's the wooden or metal mold that holds the wet concrete in place. Step 3, the concrete is cast into these columns. And then comes the most tested virtue in all of construction, patience. You absolutely have to allow proper curing time for the concrete to reach its full strength before you can safely remove that shuttering. Let's take a quick breath and recap our progress on the site timeline. We've conquered phase 1 with our excavation. We totally nailed phase 2 with our protective base concrete. And we've just completed phase 3, raising our columns and foundation walls. So all of this muddy, heavy, incredibly precise work leads right up to phase 4, the main event. Section 4, casting the plinth beam. We've finally reached the critical step of the entire explainer. Just like the base, we start with steel. Step 1, the team prepares and fixes the plinth beam reinforcement. They're essentially creating a horizontal cage of steel that connects all those vertical columns we just built. Step 2, they install the shuttering around the steel cage and do one final rigorous inspection. Once cleared, step 3 is pouring the concrete to cast a solid, continuous plinth beam with a specific depth of 300 millimeters. It flows through the steel, locking the whole shebang together into one unified grid. But wait. I have a massive, non-negotiable warning for you here. You cannot just pour concrete and walk away. You must ensure proper vibration with a tool called a concrete poker. If you skip this, you get what engineers call honeycomb. That's when trapped air creates dangerous, hollow pockets inside the dried concrete, which severely weakens the beam. Poking and vibrating the wet concrete forces those air bubbles out, ensuring the beam is a dense, rock-solid mass. Literally, skipping this step ruins the strength of the entire beam. Don't do it. Okay, so after a great job pouring and removing the shuttering, we move on to Section 5, backfilling and compacting to secure the foundation.
So, the concrete is set. The structure is tied together, but it's all still sitting in an excavated trench. Are we ready for backfilling? Absolutely. This is where we lock the foundation into the earth permanently.
Now, you don't just push the old, loose dirt back into the hole. Step 1 is to fill the area completely with a high-quality, fine aggregate sharp sand. It needs to be filled all the way up so it can be properly compressed. Step 2 brings in the heavy machinery, specifically a plate compactor. The golden rule in this stage is the more you compact, the more it settles down. You want zero empty space. Finally, step 3 involves filling and compacting with hardcore, which is basically large, heavy aggregate, to create a completely solid, immovable floor base right up to the level of the plinth beam. Finally, Section 6. Why do plinth beams matter? Why did we go through all this intense labor in the first place? Let's break down the 4 key mechanisms at play here. First, structural stability. The plinth beam physically ties all those isolated columns together so they act as one single unit against wind or minor earth movements. Second, uniform load distribution. It takes the massive, crushing weight of the roof and walls and spreads it evenly across the foundation. Third, it prevents wall cracks by stopping that differential settlement we talked about earlier. If the ground shifts slightly underneath, the rigid beam holds the wall straight so it doesn't crack. And lastly, it acts as a dense, concrete barrier against ground moisture trying to creep up into your living space. It really is the ultimate protector of your building.
So the next time you step into a building, you'll know exactly what's working overtime just beneath the floorboards to keep you safe. But it leaves you pondering, doesn't it? You now know all about plinth beams, but what about the tie beams and the roof beams hiding higher up inside the structural skeleton of your home? How do they differ from what we covered today? Well, that sounds like the perfect structural mystery for our next explainer. Thanks for joining me on site today, and keep looking deeper into the world around you.